So continuing with our idea of using our half-angle identities to find exact function values. In this particular example, we're going to use our identity, but we're given cosine of x is equal to 1/4. So I'm given the whole angle, and I'm kind of going to work backwards to find, well, what is the half angle. Now, because when we are given, generally, when we are given the domain of our function, it is for our whole angle here, or it's based on the angle x here. And in this particular example, I'm looking for the half angle of x, so I would come in and I would say, well, x divided by 2 gives me the half angle. And if I do that to x, then I have to divide all of the components in this by 2 as well. So if I do that, I can say that my half angle is now going to fall between 0 and pi over 2 divided by 2 is pi over 4. So the whole angle falls in the first quadrant, and the half angle again falls within the first quadrant in this case, but that's not always the case, as we'll see in a few minutes. So now that I have verified what quadrant it's going to be in, that is going to help me determine the sign of my answer, because in the first quadrant cosine is positive. So let's look at how we are going to talk about this. So I know that the cosine, the half angle identity for cosine looks like cosine of x over 2 is equal to 1 plus the cosine of x divided by 2, and that's all under the square root sign. So I'm going to replace the cosine of x with what I'm given in the problem. That looks like 1 plus 1/4 divided by 2, all under the radical. And we're just going to simplify this portion of my expression here. So 1 plus 1/4 is 5/4 divided by 2 under the square root. So if I have 5/4 divided by 2, that's the same thing as 5/4 times the reciprocal, which is 1/2. 5/4 times 1/2 is 5/8, and each of these have the square root, are being have the square root applied to them. Now at this point, it doesn't really matter how you simplify this. I'm going to do mine, I think, this way. I'm going to simplify the denominator by rewriting this as 2 square roots of 2, because 2 square roots of 2 is the simplified version of 8. And the numerator is still the square root of 5. Now if I were to rationalize the denominator to get rid of the radical in the denominator portion, then I would need to multiply top and bottom by only the radical part. So here I'm going to multiply by the square root of 2 and the bottom by square root of 2, and that's going to get me 5 times 2, which is the square root of 10 in the numerator, and in the denominator, when I multiply the square root of 2 times the square root of 2, I get 2 times this 2 that's left over, giving me 4. And that's the solution. That is the exact answer for the cosine of x over 2. Let's try this one more time. Given a different scenario again, but we're still going to apply our half angle identities that we're working with. So the half angle, we're asked, if we're given the cosine of 2 theta is 3/5, I want to find out what the sine of theta is using the half angle identity. So the half angle identity for sine says the sine of a over 2 is equal to 1 minus the cosine of a divided by 2, all under the square root, so plus or minus. Now, let's go ahead and let's let theta be equal to a over 2. So if theta is a over 2, then 2 theta has to be a. So if I let theta be my half angle, then 2 theta is just the angle. And the reason I needed to do that is because my formula here is written in half angles and angles, but I'm given a double angle. So somehow I have to be able to connect all of these angles together. So let's rewrite the half angle identity substituting in. the sine of theta in this case, because theta is a over 2, equals 1 minus the cosine of 2 theta, because 2 theta is a, divided by 2, take the square root. We're in quadrant 2, so we know sine is going to be positive. So we'll leave it like that. Now that I have rewritten this in a form that's going to be useful for this problem, I can replace 2 theta with 3/5. So the cosine of 2 theta is 3/5. So we're going to say sine of theta is equal to 1 minus 3/5 divided by 2. Simplify this. So 1 minus 3/5 would be 2/5 divided by 2 or multiplied by 1/2. Those two cancel, and I'm left with 1 over the square root of 5, which is going to simplify into the square root of 5 over 5. And that's the exact value for the sine of theta given the cosine of 2 theta.